Hey guys, this is the second video that comes out as part of the video series I'm doing for the book TensorFlow 2 in Action. Now, TensorFlow 2 in Action is a great book if you want to learn about the cool APIs provided in TensorFlow, as well as how to implement various exciting deep neural networks with TensorFlow. And the link to this book is in the video description, so make sure you check that out. So this video is going to be about how to install TensorFlow 2 on Windows. Now I know it's not the most straightforward thing to get TensorFlow installed on Windows and to get it working well. There are many different versions of everything and it makes it really hard, and all that complexity can really have a toll on your stress levels too. So let me make this easy and smooth for you by providing you as much as details about the process as possible. And in my next video, I will walk you through getting TensorFlow installed on Ubuntu. By the end of this video, you'll have a working version of TensorFlow 2 installed on your Windows machine, and you can dive right into that exciting code exercises found in the book. Now, before we begin, a little bit of housekeeping. We're going to use TensorFlow 2.2. Now, TensorFlow 2.2 is not the latest stable version of TensorFlow. It's actually TensorFlow 2.3. However, TensorFlow 2.3 has some really serious beef when it comes to Windows and doesn't work that well. You can find more information about this issue in the Stack Overflow question. So, the safest and latest version of TensorFlow for us would be TensorFlow 2.2. The first thing we're going to do is install Anaconda. Now, what is Anaconda? Anaconda is a Python distribution platform. This means that Anaconda manages all the affairs when it comes to Python, such as installing different Python versions, installing and uninstalling libraries, and even managing different environments for different projects. The latest Anaconda version comes with support for Python 3.8. However, for this book, I recommend Python 3.6. This is because it's much more widely supported than the latest Python versions, such as 3.8 or 3.9. However, even though Anaconda supports Python 3.8, it's not going to stop us from using Python 3.6 for this project. We can actually create a virtual environment within Anaconda with any preferred Python version we need. So let's get right into it. We're going to make a search for download Anaconda and go to the first link provided. So this should take you to the www.anaconda.com. Then you click download. And here I have a 64-bit version of Windows, so I'm going to use the 64-bit installer. When the download completes, you should find the download file here. Now we're going to run this as the administrator because I would like to install that as a privileged installation. So we're going to click next and we're going to agree to the license. Now you can set the path location for Anaconda to be installed. One thing you need to make sure is that your path doesn't contain any space characters. So here you can set like various options. So if you're installing Anaconda and would like to have that as the official Python 3.8 version of your system, you can tick this box and make sure Anaconda 3 is added to your path variable. So after you click next, well, you will start the installation. If everything goes well, in the Windows menu, you should see these Anaconda related options. For example, here we're going to go with Anaconda prompt. So the second step is going to be creating a Conda environment. A Conda environment is a virtual environment within Anaconda, and this is a great way to have different idiosyncratic project environments for different projects, which might have different needs. If you use a single environment or the default base environment provided by Anaconda for all your projects, you might end up overloading that environment. This is like using the same set of clothes when you're at home, for the parties, for work, and even while sleeping. Though it might sound like a really convenient thing to do, It's not that great in the long run, and definitely not that great for the people around you. In a more technical sense, think about a project that uses TensorFlow. It's a great idea to have an environment with TensorFlow. Then you might also have projects which doesn't use TensorFlow. Then you don't really need TensorFlow in that environment, do you? Now you see that Anaconda prompt, when you open it, it opens up with the base environment that Anaconda has by default. Now we are going to create a virtual environment called manning.tf2, and this is going to have Python 3.6. You can see that we are defining the Python version in that 3.6 argument. Once you do that, it will probably install Python 3.6 in your virtual environment. And you get instructions how to activate and how to deactivate your environment as well. Now to activate, you say Conda activate manning.tf2. And you can see that base argument in your prompt changes to manning.tf2. The next thing we're going to do is install the libraries using pip. What is pip? Pip is a tool or a package in Python that allows you to install and uninstall libraries or packages from the official Python package registry, which is known as pypi.org. In other words, it manages your Python-related package installations within that Python environment. Now, Anaconda has its own package registry as well. We're not going to go with the Anaconda version of package registries because not all the latest versions of libraries are available in the Conda package registry from my experience. So it's much more safer to use the official Python package registry than using the Conda package registry. Now we are going to go to where the code examples are. Inside that code repository, there is a file called requirements.txt, which contains the libraries and their versions we would like installed in this environment. After we go there, we would say pip install -r requirements.txt, and that will take all the libraries found in that requirements file and install them. Once the installation is done, you should see this message saying successfully installed libraries blah blah blah. If you're only interested in the CPU version of TensorFlow, you're pretty much done and you can dive right into the code examples. But I highly recommend using an environment where you have access to the GPU or any other accelerated hardware like TPUs. This is because deep neural network related computations can leverage such hardware immensely, delivering much better performance than you would see on a CPU. So this section explains how to get TensorFlow to work in harmony with the accelerated hardware like the GPU. The next thing we're going to do is install Cuda. What is Cuda? Cuda, also known as Compute Unified Device Architecture, is the language GPUs understand. GPUs have different instruction sets to CPUs, and Cuda can communicate with this GPU instruction set and make things work. Then when you execute TensorFlow code, TensorFlow will make calls to Cuda underneath, which eventually will invoke certain instructions on the GPU and get the work done for you. Now, before you start your installation, there's a critical check you need to do. Make sure Visual Studio 2015 version is installed. You can find the Visual Studio 2015 Community Edition and install that. This is a must for Cuda to work properly on Windows because it relies on certain compilers provided by Visual Studio. Now we're going to install Cuda. First, you need to download Cuda. We're going to use Cuda 10.1. So you would say Cuda 10.1 download. That should give you the official site from nvidia.com. And here you should select your options. So we're going to go with Windows. Our architecture is x86-64, Windows 10, and we're going to use the local installation instead of the network installation. But that's up to you. Then you just click download. Once the download finishes, you should see this file in your download location. Now we're going to open Cuda, and it should open up the installation. First, it will extract the installation files to a certain temporary directory. This might actually take a while. Next, it's going to do some system compatibility checks. So you agree and continue. If you're happy with the license agreement, then don't go with the express installation. Go with the custom installation because we need to do some changes. So here you can see a bunch of options that Cuda gives us to install on our computer. I don't need anything of this except for Cuda. So I'm just going to deselect all of them. And here you can see I'm expanding everything just to show you what's in there. And here in Cuda, I would just go and install everything that's found here. So it includes development files, documentation, and etc. So click next if you're happy, and it will show you where it will get installed to. Click next, and it will go straight into the installation. So as long as you make sure your graphics driver is installed and Visual Studio 2015 version is installed, the installation should go smoothly. So here I got this message saying there is a newer Insight version on my Windows machine, so it hasn't been installed. So nothing to worry about. Insight doesn't have much to do with Cuda installation in our case. So I wouldn't worry about it. And of course, it's good to have a newer version. And you will get a summary of what was installed. So just go, just take a glance at it and make sure everything is properly installed and you don't have any installation errors. Once you're happy, close it. You have a sparkling new Cuda version installed on your computer. Wow, all this installation stuff can get really boring. So let's have a little bit of trivia. Did you know that Kristen Stewart has co-authored a paper on deep neural networks? This is actually a technique known as neural style transfer. So the backstory for this is that she was working on a short film called Come Swim, and they wanted to transfer the styles from an image to the video. And well, neural style transfer exactly does that job. The next thing we're going to do is install Cuda DNN. Cuda DNN is a library that provides various primitive computations that are related to deep neural networks. And this is also a requirement to get TensorFlow working well on Windows. We're going to install Cuda DNN. So the first thing to do is find the Cuda download page. Well, if you type Cuda DNN download, it should take you right onto the page. For this case, to download Cuda DNN, you need to log in by creating an account, NVIDIA account. Only once you log in, you will be able to download this file. We're going to use Cuda DNN version 7.6.5 and make sure you choose the Cuda 10.1 version, because for any given Cuda DNN version, there's multiple versions for multiple Cuda versions. So once you click on the right one, it will expand a list of options and choose the Windows download from that list of options. And once the download is successful, you'll have this file, a zip file. How you install Cuda DNN is you just copy the files found in Cuda DNN over to your Cuda installation. So here we're going to extract our Cuda DNN file so that we can clearly see what files are in there. Now we're going to navigate into our Cuda installation. So here you can see I have multiple versions because I play around with multiple TensorFlow versions, and I have this nice organization of different Cuda DNN versions and different Cuda versions in a single folder. And this is a really nice organization of things. So if you want to follow the same thing, please do. So in 10.1, you can see I have a bunch of folders. If you go to Cuda DNN download of yours, you'll find folders with similar names. For example, bin, include, and lib, which are exactly found in your Cuda installation too. Now what we are going to do is we're going to go into each folder and copy the files found within those folders into their corresponding subfolders in our Cuda installation. Make sure you choose the right folder. So the files in bin should go into Cuda's bin folder. Files in include should go into Cuda's include folder, and so on. So make sure you copy the files into correct locations, because otherwise you will get errors. The next thing we need to make sure is that Cuda is properly added to our system path variable. If it is not added to our path variable, Windows will not recognize Cuda. So you have to go in to your environment variables control panel and make sure that Cuda is recognized in there. Great, now we have everything we need to pump up our GPUs. So let's get right into it. So open Anaconda prompt first. Then activate your environment, which is Conda activate manning.tf2, and that should give you this prompt in front of your location, which would say manning.tf2. Then you can start your Jupyter Notebook server. Once you start your Jupyter Notebook server, you will be taken into this web browser tab, which will show you different files, different notebook files found in that directory. So we're going to open a dummy notebook and run some checks to make sure that TensorFlow detects our GPU. So the first thing you're going to do is import TensorFlow. So you say import TensorFlow as TF. And once you execute that, you should see this message saying successfully opened dynamic library Cuda. So that's a good sign that our TensorFlow as well as Windows detects our Cuda installation properly. But the fun isn't over yet. We need to make sure that our GPUs are also detected. So the way to do that is by typing tf.config.list physical devices, within quotation marks put GPU as an argument. If everything goes well, you should see a list which will contain a number of elements equal to the number of GPUs you have. And if you go to that console where you opened your Jupyter notebooks, you should see this bunch of messages saying it was successful in opening up various Cuda related files. Great work, guys! We now have a working version of TensorFlow and we can use our GPUs through TensorFlow, which is the more exciting news. Just to wrap up, here's what we did. First, we installed Anaconda, and then we created a virtual environment within Anaconda that where we could install specific libraries that fits our need. Next, we activated that virtual environment and installed a bunch of libraries that we will need to run these code examples successfully. Then we installed GPU related libraries and various installations that are required on Windows. First, we installed Cuda, but before we installed Cuda, we made sure that our graphics driver is there, as well as Visual Studio 2015, because we need certain compilers from Visual Studio to run Cuda successfully on Windows. Then we installed Cuda DNN, which contains various primitive computations related to deep neural networks implemented with Cuda. Finally, we opened up a Jupyter notebook and made sure that our GPU is recognized by TensorFlow, as well as certain Cuda related files are loaded successfully when we are doing so. Great, so this is it guys. So now you're ready to dive into those exciting code examples you just want to try. Thanks for watching this video, really appreciate it, and hopefully I'll come to you guys again with another video which will explain the installation guide on Ubuntu.